Good evening, everyone. Welcome to this INNOG Tech Session. My name is Anurag Bhatia, and I'm here along with Mr. Srinath and Mr. Rajiv Sharma. We are part of INNOG Program Committee. And today we'll have this session on FastNetMon, which is an open source software for DDoS protection. And we have Pavel with us. Pavel will be taking the session. And just quick introduction on Pavel. So Pavel is the project leader at FastNetMon. He's working on that since 2014. He was very recently, actually until last month, was working with Cloudflare. As I realized after buzzing him. So very recently he has left Cloudflare, and he has worked on couple of other things around. I think FastNetMon is the thing for him now. And it's a nice open source tool. So as Pavel takes you through that, you'll realize how powerful it is for any size ISP to take care of at least certain aspects of the DDoS part. So over to you, Pavel. Thanks.
Thank you for inviting, and hello everyone. So I'm Pavel from FastNetMon project, and in this session I will provide very detailed introduction about what is FastNetMon, and stay with us all the time, because by the end of this session I will finish it with complete guide about configuration of FastNetMon step by step, with exactly every single configuration option required to enable DDoS detection and automated black hole on MikroTik equipment. So stay with us. Let's start. So FastNetMon started quite long time ago. One of the first versions was published in 2014, but I have been working on FastNetMon from 2013, because when I started FastNetMon, we had lots of different prototypes, and not all of them worked fine. But so far, what you can see is FastNetMon, which is used by many companies. And what is FastNetMon? So let's start from a little bit history of myself, because back in time I worked for many types of internet companies, domain name registrars, hosting providers, data centers, internet exchanges, telecom providers, and all of them had quite similar problems. And this was quite a significant problem, because I was a person who was responsible for running technical stack for such companies alive, and all the time I had lots of pager duty alerts, messages, calls during my night time. So it was great motivation when you wake up in something like about 2 a.m. to find out what's going on in my network. And after having like few years in this kind of quite stressful environment, I started thinking about maybe we can find out some way to find similar problems and solve it in some way. Of course, as every engineer on Earth, I started looking what we have on market. And unfortunately, after having about like 10 conversations with different vendors, we realized that we had lots of great products on market. But problem with many of them was like price, which was absolutely out of budget. Like all companies I've worked for, they cannot afford this kind of protection, but it's quite clear that DDoS protection it's crucial for company survival. It's not something optional you can keep for future, like, no, we don't need it for now, we can buy it in future when company gets bigger and bigger. It's something you need to from first steps, from first days of your company. Sometimes actually DDoS happens before you found your company. You like start prototype, and some angry guys start to think like, we don't like you for some reasons, lots of reasons about it. And that's how FastNetMon was born. So after testing many products, checking what actually we have on open source, I started FastNetMon, and from day, I would say 0, FastNetMon was on GitHub. You can find out like how it evolved, what was like bad end sometimes, because it was originally it was started in different languages, but we ended up using C++ because of performance reasons. It's quite important for this kind of software. And what we can offer from FastNetMon perspective. From FastNetMon perspective, one of the main things is automation. If you had experience with DDoS mitigation boxes in your previous lives, just ignore it completely, because typically you need lots, like you need to be full-time engineer and to maintain this kind of boxes. Lots of small configuration options, lots of manual confirmations, approvals, very sophisticated ways to integrate the network. That's all stuff you cannot find out in FastNetMon. We just don't have it. So FastNetMon was built with complete automation in mind. You are sleeping, you're having fun, you're having rest, you're having barbecue, and FastNetMon is working for you all the time without asking you for small help, big help, whatever. So what else we have? So FastNetMon was built in age when software started eating the world. And many people have different things in meaning when they say it, but instead of offering like boxes, some hardware equipment, specific configuration of specially crafted like FPGA or hardware boxes, we decided from day one that we will offer only software. Because when you start talking about like delivering some box in the middle of nowhere on opposite part of planet, you can easily spend half a year just to fill in papers. That's not a time scale we want to offer. You know, if you experience DDoS, you need solution like yesterday or immediately, or in worst cases, like in 10 minutes. So you cannot like wait for shipping of hardware equipment. So that's why FastNetMon is software only solution. It's application, tool, app, instance. Different people call it different way. And actually in FastNetMon, we offer lots of ways how you can install FastNetMon. So we are not trying to be on position like you need to change your network, you need to change your platform. As we started this great meeting today from talk about Kubernetes, if you like Kubernetes, you can deploy FastNetMon in Kubernetes. You can use Docker, you can use VMware or Zen or KVM or like all kinds of Linux containers, and FastNetMon will work all the time perfectly because we don't have any constraints about way how you can integrate it, like how you can deploy it. And one more thing is about changes in your network. Again, if you start talking about like what is the best way to integrate network DDoS detection solution in your network, many vendors will came up like you need to rebuild your networks. No, completely. You are doing this stuff wrong. But let's imagine you have thousands of routers, you have tens of thousands of switches, and what's your time to change anything? You just cannot. We need to accept that external world around us. It's something which is given. It cannot be changed because we have reasons, all of us. And that's why FastNetMon was built in assumption that we work in real world. So if this old network box talks only this protocol, we will support only this specific protocol. We will not ask you, oh, can you enable like beta version of routers or Junos or Cisco and enable this fancy feature, which may likely ruin your network. No, we try to accept what we have in place and try to live with it. And so in addition to great automation of FastNetMon, like it works for you, you don't need to change anything in your network. Like that's some small configuration changes which are actually expected, but very basic stuff you work on as network engineer on daily basis. So to enable FastNetMon on your network, you just need to establish BGP ping session, as you did 1,000 times before, and you need to enable NetFlow. This part may be a little bit tricky, but again, it's no more than a few pages from your vendor, and so it works well. And in addition to fast delivery, because FastNetMon is software, we offer really great detection time. So it actually depends on your equipment, and sometimes it can be limited and constrained by equipment itself. And unfortunately, we cannot do anything in this case. But from FastNetMon, we do our best to detect DDoS in a range of between 3 seconds and 60 seconds. And I would say 60 seconds is really worst case scenario, which almost never happens. In the real world, you will see it something like 15 seconds, maybe 30 seconds, but no more, not minutes. Why this is crucial? Because back in time, when actually I started FastNetMon, like many years ago, time difference between, like, for example, attack just started, and we can see small increase of traffic. It's like 10 megabits, 15 megabits, 60, 40, 100. It was spread over hours sometimes. It was extremely slow moving. But what we saw in even 4 years ago, it's extreme rapid escalation of capacity used by DDoS attacks. So it can be 10 megabits now. In next second, it will be gigabit. In 2 seconds, it will be 10 gigabits. In 3 seconds, it may reach 100 gigabits. And if you delay DDoS mitigation even by just 1 second, you will ruin your network and it will immediately cause downtime. And so it's one of the features in what we have in FastNetMon's DNA. Don't do stuff long. We do detection as fast as we can, and we use all kinds of tricks to accomplish it. So it's brief explanation about ideas behind FastNetMon. And all the time when we add new features, capabilities, or change something in FastNetMon, we try to follow such ideas all the time. So if something can delay DDoS mitigation, it will be opt-in option, which can be enabled if you urgently need it, but not never enabled by default, because we just really care about detection time. So again, if you are going to deploy FastNetMon, of course, we can start war about when we are talking about what is a favorite Linux distribution. We do our best to avoid talking about this kind of stuff. So if you like Debian, Ubuntu, CentOS, FreeBSD, all the time, you can install FastNetMon. We have no constraints, so we prepare binary packages for almost all major distributions. And if we see that some new distributions are emerging, for example, in recent months, we notice a significant shift of people moving away from CentOS 8 to different challenger distribution like Alma Linux or Rocky Linux because of changes in CentOS support cycle. And so we just added such distributions. We tested our product with them, and it works fine. So we're just trying to follow what market wants from us, what people want from us. So, and if you see your favorite distribution here, it's missing, ask us, explain why you use it, why we need to add it or contribute it, and we will be happy to add it. But if you have no preference, I would say Ubuntu it's a main distribution where we test FastNetMon, because almost all test machines are on Ubuntu. My personal laptop, I'm talking with you right now, runs Ubuntu LTS, lots of machines, and it's one of the most popular distribution among FastNetMon customers. So I'm not saying that if you use Debian or RHEL or CentOS, you will have worst quality of service. But lots of reasons why we prefer Ubuntu, because Ubuntu is based on completely transparent Debian. So you may not expect any changes from in pricing or in support cycle, because it's literally run by community, and it reflects ideas of FastNetMon. We're trying to be transparent, we're trying to be open, and also in addition to great package-based software by Debian, in Ubuntu you can expect very long support cycle, because of course we understand that for network companies, supporting software boxes, it's not their main business. They work with Junos, iOS, all kinds of different network operations. And of course, it's very time consuming, and adding few more machines on Linux, which need constant attention in updating it, upgrading it, changing distributions. It's not stuff you want to work on daily basis. And Ubuntu is a great option, because if you deploy latest Ubuntu version, you have at least 5 years just for security updates. So it's a great platform to run FastNetMon. If you have no preference, run it, and you will have great performance, because all the time in Ubuntu you can install latest Linux versions supplied by Ubuntu company itself, which is also a great benefit, because by upgrading Linux kernel, you can get all benefits and all improvements made by kernel development community. So in addition to Linux distributions, we have a wide range of supported platforms. Many of them are extremely exotic, and mostly we just go this list from a list of packages we prepare for Debian. But so if you want to deploy FastNetMon on your switch or router directly, try it. It will work. We tested it very well. But of course, most popular environment is AMD 64. And also ARM64, it's a rising platform, and we're getting more and more requests about how we can deploy FastNetMon on ARM boxes. And actually, we are working on native builds for ARM platform, because you can deploy FastNetMon on Raspberry Pi and avoid deploying any kind of expensive boxes in your network rack because you may not have time, or you may not have place, or you may not have electricity. And actually, Raspberry Pi is good enough to detect attacks and run FastNetMon for small networks. So you also are not constrained by anything about platform. Any exotic platform, try compiling it, and very likely it will work fine. So we live in some world, and we work closely with many vendors. It's two-way process. So sometimes vendors offer something to us. Sometimes we report bugs to vendors. Sometimes we demand something from vendors. It's a great opportunity to make our product better. And you can see we have lots of vendors here. And every single label, it's not like stuff I got from the internet. It's like every single confirmed deployment by some customer in some very heavy production environment. But if you cannot find out your vendor here, it doesn't mean that we don't support it. We just maybe didn't hear about it. And if you can share, like, hi guys, I'm using this vendor and it works fine, because this one is indeed missing MikroTik. So our fault, sorry. So we are not limited. We support all standard protocols. We have no artificial implementation and vendor logs. Like we work only with vendor X or vendor Y. No, if vendor, any kind of vendor implements protocols like BGP and NetFlow properly according to standards, we'll support it. So don't worry if you cannot find your vendor, just try it, it will work. Because that's what you can see. I would call it power of open source. Every single point here, it's confirmed deployment of FastNetMon. So you can see we cover all continents. Unfortunately, we don't have anything in NARSPOL yet. Maybe we will have soonish, but you can see great coverage, and you can find out India on this map. So lots of people use it already. So if you hear about FastNetMon for first time, that's time to add your point here and share. Like I use FastNetMon in this place. So, and it's power of open source because we have no limitations or license about open source. FastNetMon's license is very permissive, so you can integrate it in our product. It's the only one requirement from our perspective. You just need to contribute back all improvements you made for FastNetMon, or just notify us in some way, like we use FastNetMon for our platform. So let's clarify when I said like FastNetMon is really fast DDoS detection. Unfortunately, still we live in the real world, and sometimes in different scenarios we may find out different constraints and different delays about detection time. And here you can find on this slide some ballpark estimations what you can expect. So unfortunately, most popular one is of NetFlow, and it offers worst detection time, but it's something we need to live with because this one is most popular, and NetFlow protocol was built with different assumption in mind. Because, for example, if you want to keep all traffic stored somewhere for audit reasons or compliance reasons, so you don't have so many options to how you're going to implement NetFlow. If we are talking about expressing every single flow, slowly storing it in some way of database, no demand about performance. But for DDoS, we need performance. We need as fast as possible to get all information about traffic. So, and for a good thing for many vendors, like I would say, my favorite guys are Juniper and Huawei in this specific term, because they offer actually S-Flow and NetFlow in the same time. So it's up to you to decide what's protocol. So you are not limited by, like, if vendor says like we support only this one and they come in this one, is that you cannot use different ones. So check what your vendor's offering, and many vendors are adding more and more boxes with S-Flow support. And from our perspective, S-Flow is one of the best ones. You can see it's supported by wide range of equipment, simple protocol. You can check it with Wireshark easily. And so 4-second detection time in the worst case, which is great. So for about ways how we can actually receive traffic from your equipment, all kind of ways we can receive traffic from your network equipment. So typically, we support S-Flow, NetFlow, IPFix. In case if you cannot and your equipment then don't have any options to export network traffic telemetry, again, you may use Span Mirror, because Span Mirror, it's not to enable it, it's not needed to have any kind of hardware support. You can buy optical splitters. Just passive dump device as much as possible, and then just split channel and send it to your monitoring machine and listen it for absolutely passive way on some without any need to buy licenses or install additional libraries. Just install FastNetMon standard Linux distribution, and you will be able to read every single packet running to your machine over mirror interface. So simple, works in every possible case. And you actually can mix them if you want, because for some scenarios, it's maybe beneficial to run, for example, NetFlow and NSFlow at the same time for different purposes. So FastNetMon is DDoS detection software. Some people call it DDoS sensor. One important addition for explanation of what FastNetMon is, we just need to add that FastNetMon focuses on specific levels of OSI model. It's level 3 and level 4. What it actually means, so we can find out like that somebody attacking you using UDP packets, like from many machines, from single machine, that somebody is trying to misuse TCP protocol by using SYN packets or SYN ACK packets or changing window size in some ways. But if somebody is trying to like brute force password for your WordPress site, it's not stuff we care from FastNetMon. We cannot see it because in terms of bandwidth, FastNetMon cares about something which can ruin your network just by enormous capacity and enormous bandwidth of attack. If it's something very slow, like 10 kilobits per second, it's not stuff FastNetMon great with. So we focus only on stuff which is more about volumetric attacks types, all kinds of amplifications. And but if attack against your network is more sophisticated, more complex, you need to add more products in your pipeline. So you need FastNetMon will need help. It's our idea that we focus only on those levels because it's itself already very complicated. And adding level 7 protocols, it's extremely complicated too, because it's absolutely different world. Because we just cannot have information about level 7 protocols from routers. So from routers, we can see source port, destination port, source IP, like TTL fields, number of packets, packet size. That's all we can. And L7 protocols are way more complicated. So and routers just cannot see them. They don't work on this basis, and that's why FastNetMon cannot see this, get this information from routers. So be warned, FastNetMon is mostly for volumetric attacks, which can kill your routers, fill your uplinks. But you know, it's great help itself. So in terms of numbers, typically when you see like free product, because FastNetMon is indeed free, but it's not just free, it's open source. You may find out that like lots of constraints. We don't have any artificial constraints. So if you can see that FastNetMon is not running very well, it may be some just need of optimization or improvements in source code or design change, but never artificial like licensing or whatever limitations. So all such numbers on this slide we got from real customers running FastNetMon Community Edition. This one is not about commercial edition. This one is exactly about FastNetMon Community. So you can get such numbers. Of course, in some cases, it may mean that you need to do some tuning for your machine, some improvements, kernel tuning, but it's definitely doable. So yeah, typically, in most cases, if you're on small or medium-sized networks, you will never face any constraints or limitation about performance from FastNetMon. Just deploy it on decent machine, like it's 4 cores, 8 GB of memory, and it will run at FastNetMon happily for years. What we can do, because we work in network environment and we are trying to talk in network language, and because very common for software product to talk software ways, like software way of interfaces, like kind of XML API or JSON API or HTTP callbacks, but it's not language routers can understand. That's why our main language talk with external world, with routers, switches, upstreams, is BGP. And we use 2 alternative daemons for injecting BGP and reading actually incoming BGP announcements. We support EXA BGP and we support Go BGP. Again, it's exactly the same story as with Linux distributions. So no preference. If you already have ExaBGP or GoBGP, just use it because you're already familiar with this software. And one important thing to note is that like those daemons, they are not part of FastNetMon package. We provide a great API integration with both of them, but we don't ship them. So if you have any questions directly about GoBGP or ExaBGP, they're separate projects. Ask them, provide help for them, feedback, ask for help. So from our side, we'll be happy to help, like what's your best scenarios, but we'll be more productive for you to talk directly with authors. So, and in addition, if you actually need to integrate your DDoS detection pipeline into something existing, we have a separate script call. And script calls, it provides all basic information about attack, like target of attack, direction of attack, protocol of attack, actually power of attack, how much packets we have, how much gigabits we have for this particular attack. And then you can call any kind of script. It may be Bash, Python, it may be Perl, Ruby, Go, whatever. You are not limited by any ways. So you can, instead of, for example, using BGP protocol, you can like run some command on your router, for example, remove some specific prefix or move it away from one upstream to a different one. So this complexity of integration is limited by only your imagination and the amount of your spare time you want to invest in. But for most common scenarios about automated black hole or diversion to cloud scribing center or diversion in on-premise scribing equipment, you can use just BGP protocol because it works just best. We tested with plenty of vendors. It's very efficient, very fast, and very reliable. So again, and you did it many times because every single network engineer works with its main protocol actually work with and on a daily basis. And that's why we focused on supporting it very well. To deploy FastNetMon, you will need no more than 15 minutes. It's not marketing talk. I'm not saying like, you deploy it immediately. No way. I will prove it because after I finish the introduction slides, I will provide how you actually can deploy FastNetMon in exactly 15 minutes. So stay with us. And in FastNetMon, it's very simple to configure. Because most of the stuff, you just need to enable FastNetMon, make some changes on your network equipment side, and enable a few options on FastNetMon side, and then FastNetMon will start working immediately for you. And after that, of course, you will need to adjust some changes, some options for your specific network, but deployment cycle is extremely short. So it's crucial when you are actually under attack. It's 2 a.m. on clocks, and you need to do something fast. So FastNetMon is your choice. FastNetMon is quite simple app. Again, simplicity was one of the things we tried to maintain all the time. We don't have any kind of DPIs or like as it's called nowadays, artificial intelligence or machine learning. No, because of course we have plans for some future, but for now, FastNetMon is very basic and you can understand how it actually works. So it's more, from this perspective, it's more about network automation because how FastNetMon works, it just calculates bandwidth for every single entity in your network. With utilization of different protocols, for example, how much this specific host, I mean /32 or /128 in case of IPv6, generated incoming packets, how much outgoing, how much TCP packets, how much fragmented packets, and then you can set threshold after which FastNetMon will identify and call all actions. So for example, if traffic for any host in your network exceeds 1G or like 100,000 packets per second, call this section or black hole it, because how you can actually adjust and find out what is the best threshold value. Threshold value, it's actually value when your upstream is filled and started dropping packets. And it's actually value when your routers will stop moving packets around and will stuck and will start losing packets. That's the time actually. So it's a level of network degradation and you need to set FastNetMon to this specific value. And then instead of like using APMI or actually traveling to your data center or NOx rack, on car, on like physically, you just need to set such values on FastNetMon, and before your network starts degradation, it will cut all traffic, and then in calm and quiet environment, you will deal what actually happened and what you can do to prevent it or mitigate it. One of the most common scenarios how people use FastNetMon, it's automated black hole. Of course, it's widely used, so you just kill specific host which is target of attack. That's all. Next, very popular scenario when people use FastNetMon, not just black hole it, because by black holing your host, you literally accomplish goal of attackers. You just shut down your specific host, and then you have no options like to save it. But in addition to this kind of scenario, you can use external scribing center. Of course, they are more expensive because FastNetMon is free for you, and but you can find out some affordable cloud scribing centers. And in this case, FastNetMon also can help you because instead of blocking specific host in your network, FastNetMon can create API callback or BGP announce in the BGP ping session you maintain with scribing center, and it will move all traffic for affected prefix, because in global internet we cannot move single host, which is /32. We can operate only on basis of at least /24, and FastNetMon can do it for you. It can identify what host is, what prefix is a target of DDoS attack. And then it can announce it into BGP session or notify your scribing center API, and all traffic will move. I would say all malicious traffic will move away from your network, and will move to scribing centers, will be filtered out and delivered to your machine. So it's one of the options how you can use FastNetMon. This one is like stage 2, because after you solve the original problem and your network is not dead anymore, which is great, you may think, what's the best way if I want to save this kind of service? And it's absolutely unacceptable to keep it shut. And one more case, if you already have some kind of equipment for precise filtering, you also can use this kind of equipment with FastNetMon, because FastNetMon can redirect traffic not only to cloud scribing, but it can redirect it on-premise deployment of multiple smart boxes, which can filter out traffic. And it adds one more level of attack defense. So because you can, in this case, such boxes may work on level, for example, level 5 and level 7, and filter out traffic very precisely, in addition to quite basic options to filter out traffic offered by FastNetMon. So if you have any equipment already in place, think about it, because we have no constraints how you can use FastNetMon. Just to think about what's the best way, what you can do, what's your best scenario, what you can reuse in your network, or what you can actually buy. So this one is diagram about what is black hole and how it actually works. As we explained it previously, FastNetMon, on the left side, it's your routers, it's your maybe switches, because nowadays it's quite complicated to find out what is a router, what is a switch, because when you see switches with like 4 million routing countries, it feels like router. So you need to send some information about traffic from your router or switch to FastNetMon. In exchange, fully configured FastNetMon can notify your equipment about DDoS attacks by triggering BGP announces to your router, to your switch, or directly to your upstream. It's also a possible option. And when FastNetMon actually detects attack, it creates special announce on basis of /32. And also it sets specific community. Typically, this kind of community is set by your network administrators and your upstream, because typically it's a well-known community number for black hole is 666. So what actually happens when FastNetMon finds out that specific host, like for example 1, 2, 3, 4 /32, is a target of DDoS attack? First of all, FastNetMon will find out that like bandwidth or packet rate for this specific host is enormous, and it's exceed threshold set by system administrator. For example, maybe more than 1G and more than like 100,000 packets per second. After that, FastNetMon creates special announce or using BGP protocol, and provides information to your routers. So announce looks like you can change next hop configuration for it. You can change community number, and that's literally all you can see, what you can change. So on your router side, what your routers need to do, and that step, you need to change some routing policy on your network. It's not that complicated, but just you need to keep it in mind. So what you need to do from your routers, when FastNetMon actually announces some specific host /32, you need to change your router's routing policy to discard every single bit of traffic towards this host. It's your first level of defense. If a specific attack is not filled and it's not reached limitation of your incoming channels, you still have some spare capacity, I mean, in terms of forwarding and routing on your router. This one will delay time when your network actually dies. So it's first step. Instruct your routers to discard as much as we can. Because FastNetMon detects attack very fast. And we still have time when attack is not that big enough. So it may be hundreds of megabits or gigabits. We still can do it. And next and most important step, because this step is optional, you may ignore it and you may not think about, like, in some cases, you don't need to discard traffic on your routers. But you have high performance routers and you have lots of incoming bandwidth. It's definitely an option for you. But next thing is more important. So your router need to re-announce this specific black hole announce to your upstreams. And that's where magic happens. So in terms of 60 seconds or a little bit more, sometimes it's 90 seconds, sometimes a little bit more than 100 seconds, every single router across the planet will stop sending traffic to your specific /32 host in your network. And it will literally slow down attack for its first time because of propagation delays over BGP. It's not instant process, but in worst case, in a few minutes, you will notice that every single bytes of incoming and attacks attack, stop it. So you kill it attack. What is the problem with this step? Actually, no problem, because for some cases and some services, it's absolutely expected for you and absolutely possible to stop service. It may be some customer, single customer, which causes this kind of attack. It may be single service, which is not really important for your company. Or it may be poor translation gateway, which can be easily renumbered. So not so many cases when you actually need to keep it running. So you can just kill it and then replace it, renumber it, and keep it running. So that's how it works in many cases. But what happens if your company provides just single service and you just kill it using this approach? And it's time when you need to think about what you can do next. Because many people may say, like, RTBH or black hole, it's not a mitigation, but I would say it's a mitigation. But we are talking on different bases, because when we do RTBH, we literally manually kill traffic to our specific host. It sounds terrible. We kill traffic. Not attacker did it, we did it, but we saved our network. Let's imagine every single network, it has at least hundreds of IP addresses. It may have millions of IP addresses, but we find out what was the original and real target of this specific attack. And we sacrifice this specific host and this specific service to keep network running. Because if we compare single host without service and millions of hosts without service, it's obvious to see that it's indeed mitigation. It's one of the popular and most efficient ways how you can mitigate attack. And of course, if you cannot block this service and you cannot survive without having the service. Next slide talks exactly about this way. Here's one, of course, is more complicated, because in this case, you will need to pay for external scrubbing center, which can actually clear and filter out attacks traffic. Because if you, for example, your company has just 1G or 10G of external uplink, and attack reached something like 100G, you literally have no option how you can do anything about it because you just cannot receive it. No points to try to filter it out on routers. No points to try to filter it on firewalls. No, really, it will not work. But only one company which can help you, it's your ISP. Some ISPs, they may offer scribing center or filter out something, but it's not guaranteed. Of course, it's something optional. You need to discuss it with your ISP. But in most common cases, it's external company. You may find out many of them in your region. And they will receive every single bit of attack and your real traffic, process hundreds of gigabits of malicious traffic and real traffic, and then deliver all traffic using private network interconnection called PNI, private peering, or GRE tunnel to your routers. And in this case, FastNetMon also can do it for you because instead of making just black hole, FastNetMon can announce affected /24 towards scribing center, and all traffic, including malicious traffic, your good traffic, will move gracefully away from your network, and your uplinks will be empty, not filled by malicious traffic, and we'll move it to scribing center and deliver it, and only clear traffic will be delivered to your service. So you can save your important service, and again, keep your network running. So instead of like having spend hours to find out what is the target of attack, because without FastNetMon it will be extremely complicated, because if you miss a DDoS attacks, like you notice that something's bad, but when you notice that something bad, attack is already escalated and accomplished his goal. Your network is degraded, your services experience packet loss, your service is inaccessible for many customers. So that's all. But problem is, it's also inaccessible for you. You cannot easily log into your routers. Of course, it's expected to have like out-of-band connection, but it also may be filled. So it's very complicated and it's very stressful. And if you are working as network engineer, it's in your clear interest to keep your amount of stress in this scenario low as possible, because even if FastNetMon detected attack for you, you'll need to think about what you can do in future to prevent it. You need to arrange contracts with scribing centers. You need to apply configuration to enable scribing center. It's some time needed. You need to talk with your who is actually responsible for service, which was a target of attack. You can see it's lots of time, it's lots of work, it's extremely important work. And if in the same time you will fight DDoS manually, making black hole announcers manually with your hands in the middle of night, it will not work. You have way more important things and project to work on. So delegate this problem to FastNetMon because it can do it for you. And in addition to nice automation, FastNetMon supports nice graphs. We support Grafana for visualization. You can see such graphs from Grafana. We support time series databases such as Graphite and InfluxDB. So you can find out like what is the traffic bandwidth or packet rate for specific host, network, or specific or total numbers. Because this one, even if you are not interested in DDoS detection, you may be very lucky person who actually never experienced DDoS. But this information also very nice because you just need to enable NetFlow. We don't use SNMP protocol at all because it's extremely complicated. It's vendor specific. You don't want to worry with it. And for this one, you just need to export traffic telemetry on FastNetMon, and you can find out how much specific host generates traffic, how much TCP packets you have in specific subnet, which is great because even in context of DDoS detection, it's in your clear interest to understand your network as much as you can to find out like this host generates 1G of traffic, and it's not attack, it's normal traffic. Because, lots of mistakes people do when they try to fight DDoS attack, because when you see enormous amount of traffic, you may miss like what is actually malicious traffic. And unfortunately, back in time, I did this mistake by myself because, this one looks strange. And it was just voice traffic from one customer. And it wasn't DDoS attack, but sometimes it actually looks like DDoS attack. It's why you need to understand what actually happens in your network. So when FastNetMon detects attack, it provides lots of information about what is this attack. And you can find out lots of metrics and lots of counters in this specific case, but more about it's like different types of packets, different types of traffic, and it helps to understand what you can do against this attack, or just understand like what can be done against it. But for example, because for example, if you experience a UDP attack on service, which is actually TCP only, you may think about just using static ACL to discard every single UDP packet, and it will work fine, and it will save you from DDoS, and it will save you from reaching sensitive and to traffic spike service, and discard all bad traffic on routers or switches. So FastNetMon can call scripts. And you can see simplest possible script, which actually implements email alert you saw on previous graphs. So in this case, it's implemented on Dash. It may be any language. We just provide all information using command line arguments. It's most important information like about what action is like ban or unban, or what is the peak performance of attack. But in addition, we provide lots of information, like you saw again on previous graphs, about like key metrics for a specific attack. So you can use this information. You can create Slack alerts, Telegram alerts. What else? You can use PagerDuty, or you can use WhatsApp. Many of options to notify everyone in your team that we are in serious troubles, we're experiencing DDoS attacks. But fortunately with FastNetMon, most of the case will be just alert, automatically mitigated, no action needed. Fine. And FastNetMon even can block it host for you after like some specific time passes, and by default it's around half hour. And of course you can change it. So you just need to monitor what happens, check what's at FastNetMon working well, and that's all. You may ignore it. And FastNetMon is quite simple to configure, but you can see like we have many metrics, but most of such metrics, it's not about crucial things you need to change in FastNetMon, because we support many different ways how you can actually collect traffic from your network. And for all of them, we have some number of configuration options. But you can see next slides in videos, this stuff mostly is optional for you, because if you use just simplest option in this NetFlow, you just need to change about 3 options. That's all. So we are just most exciting part of my presentation. We actually will start to change configuration for FastNetMon from step when we actually install FastNetMon on Linux server to step when we actually integrate and create a BGP black hole announce. So let's start. So to deploy FastNetMon, you need a Linux. In this specific case, I used Ubuntu 20.04 LTS. Again, it's our favorite distribution. If you have no preference, just use it. So, one second. So on this screencast, I will start commenting what actually I'm doing, because I did it myself, and I would like it for you to understand what every step means and why we did it this way. So before we start, we expect that you have physical server or virtual machine with Linux distribution installed. We are not talking about installation of Linux itself. So it's, you can use images, you can install it using official compact disk. If you still remember what compact disk is. And so we have no constraints. And we just need to have SSH session or local console session, because you even can run this command from air-gapped environment without even internet access, and it will work. So first of all, to deploy FastNetMon, we actually need a very limited amount of resources. If you have just single server, you have no options. Try to run FastNetMon on it and ignore minimum configuration options. So because if you have just single box, you have no choice, and very likely FastNetMon will work. But if you have choice, if you're deciding to looking to buy new equipment, look on something at least with 4 or 8 CPU cores, at least 8 GB of memory and at least like 100 gigabytes of solid state drives. FastNetMon is not using any a kind of persistent storage itself, because every single thing you can see in FastNetMon is mostly calculated in memory. But what important for you, if you want metrics, for metrics, you need to install InfluxDB, which is a recommended way to implement graphs using FastNetMon. But in this case, you will need lots of disk resources, and it's preferred option to use solid state drives or NVMe drives. And don't use spinning graphs, because it's old stuff and you don't need so much disk space for FastNetMon. So of course, so let's assume we just first time log it into the machine and check that it's actually Ubuntu. Fortunately, it's latest Ubuntu with all updates installed. Next thing, so first we use Unifit installer, which actually makes some configuration changes for your Linux machine. And then it checks what's your distribution, what version of your distribution, and just downloads binary package. Don't be scared by our installer. It's not some dodgy stuff happening behind closed doors. We just change few sysctls and download deb or rpm package and install it using standard package manager. It will not ruin your system. If you are not happy with FastNetMon, only one thing you need to do, just remove package. That's all. So no compilation involved, no done like some malware installation, of course, as you may expect for if you're familiar with different installers. So this one is very simple. And if you are not happy with our installer, you can download packages directly. But we don't recommend doing it, because all the time we did invest lots of time to implement this kind of installer, and it does many magic things. If you avoid doing them, it will cause problem. For example, our installer changes default UDP buffer size, because, for example, many routers, they export traffic evenly. It's like it arrives in like 10 packets per second, whatever. It streams even, not without burst. But what, for example, actually vendors like MikroTik do, they like for 60 seconds you expect nothing, but then in 1 second it pushes tens of megabits of telemetry to collector, and of course it causes issues. It drops every single packet it's received because the default size of UDP buffer is small. That's why we change it. So let's download our Unifit installer. It's quite heavy, unfortunately. It's implemented in Go language. Okay. Done. So next thing we need to set execbit, because it's not script, it's not something implemented in Ansible or Salt, it's just binary tool. So, and two purposes of installer: to make some changes and configurations for your machine, and to install packages. And of course, when you run installer, it will notify that you have commercial version, which is or way how we actually support the development of free version and community version. And so all the time, feel free to check what changes, what improvements you may find out in advanced version. And we offer, for commercial version, we offer free trial, so you can try it if you want, but no obligation. And in this case, we ask you for your email. Why this email is important? So don't worry, we are not going to spam you. In worst case, you will receive just one email per quarter. But according to previous information, typically it's one email per year. So we'll send you only information about if we or somebody else find out security issues in FastNetMon. It's first thing. We will use this email to immediately update FastNetMon. We sort it out and find out something very dangerous. And next thing is, it just motivates us. Why? And it's the reason why you need to use, if you can, to your corporate email, not your Gmail. Because when we see some random guy using Gmail, we are happy because somebody else using our product. But when we see big company using our product, it makes us proud as everyone else. Like, look, it's a great company, it's a big company. If FastNetMon works for them, it makes us excited. It's a great reward to see. So if you can, please fill your real business email here. We are not going to call you. We are not doing any outbound sales. No weird person will call you. We may send email, just like I mentioned, extremely rarely. That's all. So in this case, unfortunately, I violated it. I used my Gmail, but I know what is this guy, Pavel Odintsov. So, and next thing, so wait for some time to download binary packages. In terms of disk space, FastNetMon package is around 100 megabits. Why it's so heavy, you may ask? So the reason why, because we carry every single dependency inside of our package. So we don't use dependency on your Linux machine, because you can see we support extremely long range of distributions. So that's why we avoid using them from distribution, and we just compile everything. We use more recent version and more performance optimized versions. So that's why it's heavy. So, but I hope it's not a problem for you. So check that FastNetMon installed properly. Latest version of FastNetMon, it's 1.2.0. It may happen that you installed FastNetMon previously, or you actually used FastNetMon from your distribution, because FastNetMon is a part of official Ubuntu, Debian, and FreeBSD distributions, and you may have it previously. In this case, you need to back up your configuration and install FastNetMon again using core installer, because this one installs latest version. So all features, all bug fixes, all kinds of things we do in like previous years to improve FastNetMon. So in this case, it's correct version. And check daemon status, because yay, it's running. So you may see FastNetMon is running, no issues. It started automatically for you and ready to help with DDoS attacks. So that's really all steps you need to do to install FastNetMon. Actually, because this specific machine, it has quite a slow internet connection, but for your machine, it's maybe like, you may install it in 15 seconds. So what else? So we have FastNetMon. It's running, but we have no information about traffic. And it's most exciting part. For this workshop, I used MikroTik deployed in cloud. To be completely clear, it was MikroTik CI chair on latest stable version of routers. And on this step, we deployed FastNetMon. It's running, but we need to send traffic information from MikroTik to FastNetMon. And let's do it. So for my tests, I used Winbox environment, because it's very convenient. I really like MikroTik's environment because it's very fast, and it immediately updates all configuration options. It's not web page. It's really great. So to enable NetFlow on MikroTik, it's actually very simple. So you need to open traffic flow settings. And most important thing, of course, you need to click on enable flag, and you need to select interfaces you want to export traffic from. So when you first time deploy FastNetMon, please try using all interfaces, because to avoid issues like I cannot see traffic, I cannot see anything. In future, you may change it, but for start, just have for interface. Cache entries, it's 128 Ks. In some old routers models, versions, it may be a very small one. This one is good enough. But what is the most important stuff? Most important stuff in this case is flow timeout. This part is the most complicated part of FastNetMon itself. Be very careful. So what is active flow timeout? Active flow timeout, it actually means when a router, in this specific case MikroTik, still see active flow. I mean, it may be connection to YouTube, downloading some video, and this flow is active. And active means that it wasn't terminated by sending FIN packets, or it wasn't terminated by timeout in case of UDP. And by default, MikroTik will export information with 30-minute delay. It actually means after you downloaded file or somebody attacked your network with an enormous DDoS attack, you will know about it in 30 minutes. It sounds not great, you can see, because your network will be dead by the time. So this stuff is most important. You need to change active and inactive flow timeouts. And if your vendor is different, it doesn't matter at all. So Juniper, Cisco, Extreme, Arista, Vias, all the time you need to change active and inactive timeout to 15 seconds. And what I do in this presentation, so we remove 30 minutes, replaced by 15 seconds, and every single traffic, every single packet observed by router will be exported to FastNetMon or any kind of router, with no bigger delay than 15 seconds, which is great. So it may be better, but it's still great. So next thing, we just can overview what we have for IPFix. FastNetMon supports both options, NetFlow 9 and IPFix. It's up to you. If you want to use IPFix, use it. In this test, I used NetFlow 9. Actually, NetFlow 9 and IPFix are extremely similar protocols, and it's up to you to decide what is the best protocol for you. FastNetMon supports both of them. No differences in performance features, so it's up to you to decide. So, status. Finally, after we enabled actually flow tracking, we can see some active flows. So because on this machine, I was logged in using SSH, and for Winbox itself, we need some sessions. So active flow F5 is about right, which is great. So it started tracking flows. And next thing, it's most important one, after we enabled NetFlow, we need to set FastNetMon's address. This one is the address of FastNet machine where you deployed FastNetMon. Feel it? It's my machine. If you have no reasons, I mean specific reasons in your network to change default port for NetFlow, don't change it. Because you will simplify your life, you will simplify life of your colleagues, teammates, just to understand like what is this weird traffic. Everyone understands that 20, 50, 55, it's NetFlow. Keep it this way. But of course, FastNetMon can support different ports, but again, you will need to change one more option. What is IPFix template refresh and template timeout? It's also quite an important option. And you need to understand that NetFlow 9 and IPFix are template-based protocol. What does it mean actually template-based? Because most of the time, I would say 99% of time, router does send binary blobs. And problem is, what's binary blob? It's just chunk of bytes, typically around 1,000 bytes length, without any meta information. It's just absolutely arbitrary number of bytes. You have no idea what's inside of it. You have no idea how you can actually decode it. What is the location of source IP, destination IP, or packet length? And that's why, and what we store in templates. Templates is just a guidebook, what inside of packets router is sending. And those protocols are implemented this way to reduce number on router CPUs, just to export really crucial information. And the meta information is updated on some way like longer time. So you may expect thousands and like tens of thousands packets of data, which actually carry information about your traffic, but router will send information how you actually can decode it every 60 seconds. So that's why first time when you start FastNetMon, it delay about DDoS detection will be a little bit longer because FastNetMon need to learn this information. But again, default configuration was about half hour, which actually means for half hour, FastNetMon will not be able to decode any information because it will be look like, oh, it's Greek for me. I have no idea how I can decode. And after that, it will receive this information. We set it to 60 seconds. So routers will announce information how FastNetMon can decode information from MikroTik every 60 seconds, which is great. So we don't need to introduce more delays because NetFlow is quite slow itself. That's all we need to enable traffic configuration export from MikroTik to FastNetMon. So we can see it's exporting traffic. Mission accomplished. What's next? At this point of time, we have traffic flowing from MikroTik to FastNetMon, and FastNetMon is installed but not configured at all. Let's do it. Again, I will show you that FastNetMon configuration is extremely simple. So, 1 second, not so fast. So this presentation is one of the largest. If you have water, coffee, or what else. So let's start. So first of all, I will open interface statistics on MikroTik, and I will open resources window. Why? Let's look why. Because we're going to check how FastNetMon can detect attack, we need to emulate some artificial attack, and I will do our internal app to generate some amount of traffic here. And on a machine with FastNetMon, we will start TCP dump. Why we need TCP dump? Because especially in complex networks, you need to understand and confirm that your machine, where you actually deployed FastNetMon, actually receives NetFlow information. I would say it's source of about like 25% of requests to FastNetMon support or community channels. Why I cannot see any traffic in FastNetMon? The reason is your machine has no traffic for some reason. So it may be firewall, it may be some misconfiguration, all kinds of strange things. And you don't want to spend your time to confirm this is problem of FastNetMon, because FastNetMon is quite complex piece of software and you have no idea how it works. You need to ask authors or check source code. It's a long time, because that's why you need to confirm that this machine, this FastNetMon, actually has some traffic of coming from MikroTik. I mean, NetFlow traffic, not real traffic. And after I launched TCP dump, we can see one packet. Let's look what we can do. So normal traffic for this machine is extremely small. And we can see some NetFlow, but the amount of NetFlow is extremely small, like 2 packets, it's nothing. Maybe it's sending something, but it's not information about that. What we can do, let's simulate some, like in this particular case, what I actually did, it was just was a speed test using very large packet rate. So let's start packet generation. Keep your eyes on left. So look left side. So CPU load, it was 1% or 0%. Now it's 18%. So 18. And you can see we are having about 15 megabits of incoming traffic and quite serious amount of packets. It's 46,000 of packets. It's not enough to kill this specific MikroTik, because this one is deployed on quite powerful machine. But if you're talking about small MikroTik, if you increase this amount of packet rate by one level of magnitude, like few hundreds of packets, it may start degrading your real traffic, and it will become problem. So we start at the official stream. We can see that CPU load on router increased. And we need to confirm that router will actually export information about this traffic burst to machine with FastNetMon. Let's wait. So TCP dump shows that some occasional packets arrive from MikroTik. But again, we generate a serious amount of traffic. It's not 5 packets, it's nothing. Let's look. Is it working? Maybe it's broken. Maybe it's not sending everything. Maybe we did not set NetFlow for every single interface where we actually see, oh, nice. You can see those enormous burst of traffic. You can see it's like just like between few microseconds between packets. It's enormous burst. And this one was attacked. It's microtick aggregated and waited for 15 seconds and export like, guys, look, we have serious problem with DDoS attack. So it works, definitely works. So next step, we need to change FastNetMon configuration. It's not that simple. It's not that complicated. Look. So we need to open FastNetMon. Your friend is tool called FastNetMon_client, which shows every single important piece of information about your network. It's like helicopter overview. What actually happens in your installation of FastNetMon? Not so much happens. Actually, you can see we have incoming traffic 0, outgoing traffic 0, internal other traffic 0. Not fun at all. So why? Answer is FastNetMon has lots of options how you actually can capture traffic. And we are not enabling all of them by default because it may be security issue. Because NetFlow protocol is quite a dangerous protocol, and you can do many weird things using NetFlow templates. That's why we don't enable anything by default. But if you want, you need to do it. So your journey starts here from etc/fastnetmon.conf. This configuration file has every single piece of information, every single configuration option you need for FastNetMon. So we need to make some changes because we are going to use NetFlow protocol. And remember, on previous steps, I said, like, don't change ports for NetFlow. And we used standard port 2055, and it's fine. NetFlow host is 000. Don't set here your router's IP. It's not your router's IP. It's also quite a common misconfiguration. This one, it's IP of your machine with FastNetMon or 000. And 0 is special. 0 means that FastNetMon is on every single interface on your machine where you deploy at FastNetMon. So, and if you have multiple interfaces receiving traffic from multiple segments, it's fine. Use 000. No reasons to change it. So, no changes in this step. What else we have for NetFlow? Next thing for NetFlow, we have sampling rate. Sampling rate can be changed from configuration, but in most cases for all versions of NetFlow, FastNetMon can find it out automatically and set it for you. So no reason to check it unless you absolutely need it, unless you notice something wrong. So again, no changes in this case because MikroTik has no support for sampling. And most important thing, this configuration option controls plugins. Plugins actually receive traffic from using different protocols, and we need to enable it. And in this particular case, we just need to change it from off to on. And also one of the things which is cause a constant frustration of FastNetMon client. Oh, sorry. So it's average calculation time and speed calculation delay. Those values, they must match configuration options we set for active and inactive flow timeouts. Remember, we set both of them to 15 seconds. And options called speed calculation delay, it must be a little bit bigger than average active and inactive timeout. It's extremely important. If you mess up with such values, FastNetMon will calculate traffic weird way. It can overestimate it or underestimate it. Such values are extremely important for correct traffic configuration. That's what we do. Look, default options, they don't work for any options. They don't work at all. So because we need to change them all the time. So speed calculation delay. So we set average calculation time and average calculation time for 7 to 1. It's one of the ways how you can configure FastNetMon, just follow it. But speed calculation delay must be set to a little bit bigger than 15 seconds. In this case, we set it 30. What is this value? It's actually how often FastNetMon will calculate traffic for every single host. So for 29 seconds, it will just increment counters about how much bytes we observe it in incoming and outgoing directions. And on second 30, we will calculate how much actually traffic, what was bandwidth of traffic. So it will calculate, it will divide total number of observed bytes by 30 seconds to find out what was speed of it. it's very significant simplification how it actually works, because internet is exponential moving average, but that stuff you need to do. So in this case, it's 30 seconds. If for some reasons on your router you have timeout like 60, this value need to be like in range like 80 or 90. That's most complicated part, and if you understand it, just use your flow. You actually can use the exact number of flow active and inactive flow time, but in this case, if routers delays it a little bit, you may expect that inaccuracy. That's why we little bit increase it. So, and that's all. That's every single option you need to change in FastNetMon to enable NetFlow. You can see no options needed to change at all. That's what I do. I save this configuration file, and I was able to leave Vim editor, which is, quite great accomplishment. So what's next? All the time, FastNetMon need to be restarted all the time when you change configuration. It's quite unpleasant, but it's extremely complicated to apply all configuration changes in runtime, because we need to bind on more sockets, we need to reallocate counters. That's what we do. So all the time when you apply any kind of configuration change for FastNetMon, you need to restart it every single time. What we did, we restarted it. And next thing, again, our friend FastNetMon client, look what actually happens. Because on the left side, you can see that our packet generator still generates some amount of traffic. It's around 7 megabits, a little bit more. And on FastNetMon, because of flow export delay called active and inactive timeout, we have delay between time when actually a MikroTik absorbs traffic and when it exports information about this traffic in NetFlow packet. Wait, patience, my friends. So, yay! So, look at left side. So, FastNetMon calculated traffic amount 22,011 packets per second. Actually, it was 22,489. Of course, you must not expect absolutely precise values here, because it's what FastNetMon is using. It's approximation of traffic bandwidth using information from NetFlow. It's quite inaccurate by default, by design. It cannot be absolutely correct. But we are talking about some differences around like a few percent. So because why counters from interface itself are different from NetFlow? Because NetFlow protocol, it's in nutshell, it's very different. Because for port counters, we include Ethernet headers all the time, because we just calculate every single bit transferred over interface. But what is NetFlow? NetFlow has information only about IP packets, IP flows, and it just excludes information about Ethernet header, which is in case of small packets can be quite significant. So that's why we may expect some difference all the time. But you can see it's very similar. But actually, packet rate is very similar, but bandwidth is a little bit smaller. That's actually why. That's explanation, because we generate traffic using very small packets, about few hundreds of bytes, and because of some differences about Ethernet header, so it's a little bit smaller. So, and if you generate this traffic using real world traffic, I mean, not artificially generated, those values will be way more precise and way more close to real information. So we have got traffic, FastNetMon can see traffic, FastNetMon can definitely read NetFlow information sent by MikroTik. But what does it mean as a traffic? What is it? So it's time when you need to think and listen for me. So FastNetMon has options to classify traffic using that some traffic is incoming, other traffic is outgoing. How we actually can do it? Some implementation of NetFlow collectors, they use information about direction from NetFlow or some kind of heuristics. We don't, because in case of complex networks, it's extremely complicated to understand which interface is outgoing, which interface is incoming. That's why we don't do it, and that's why we ask you to specify a list of every single network in your operated by you. All prefixes inside their format, you need to set them to FastNetMon. Until you do, FastNetMon will track all traffic as other. And also, you may notice that internal traffic is traffic which is originating in your ranges and arriving to your ranges. And FastNetMon ignores this kind of traffic completely because it means that it's your hosts exchanging traffic between each other, and we are not interested. We are not expect DDoS from your own host. Unfortunately, it may happen, so be warned. And there are options how you can actually disable this behavior, but this behavior is default, and for most customers, it works fine. So what's next? We want to see this traffic in incoming and outgoing. That's why we need to provide information about what is the explicit prefix operated by us, what is the list of prefixes operated by our network or autonomous system number. And to implement that, we just need to make small changes for FastNetMon's configuration. And let's do them. So in real scenarios, it may be quite complicated to find out every single prefix operated by your network. And because that's the reason why some customers, they export this information from BGP and update networks list in FastNetMon on daily basis or on hourly basis. And so again, we don't keep a list of prefixes in FastNetMon conf. Why? Almost everything about FastNetMon can be changed in FastNetMon conf, but not this one, because we keep it externally, and we did it to simplify management of your network list from your script. So again, you can use your BGP session and retrieve every single information about what prefix is operated by your network automatically, so without using hard-coded value. But in this case, because it's my lab, I need to set this specific prefix because this one was assigned to my machine with MikroTik. So let's do it. Of course, in a real world scenario, you may have thousands of prefixes here, and FastNetMon will handle all of them without any problems. So we use very efficient Patricia 3 implementation. So don't be scared. Again, you need to restart FastNetMon after making any single change. So let's wait. Expected change that other traffic will become incoming traffic and outgoing traffic. Again, we need to wait until MikroTik exports all information and until FastNetMon calculates all information about received data. Yay! So it actually happened. First time in your case and in our life, FastNetMon blocked traffic. What happened? So you can see FastNetMon correctly split traffic, which was previously counted as other traffic, as incoming and outgoing. And of course, for outgoing traffic, we can see some packet rate. I would bet that this one is ICMP port unreachable or something similar, because we flood machine with enormous traffic. And incoming traffic at 23,000 of packets per second. And it was banned. What does it actually mean, banned? Sometimes people expect that FastNetMon will block something, but look on left side. No, there are no changes for packet rate. It's still 22,000 of packets per second, around 7 megabits, no changes. And that's a quite important thing to understand. FastNetMon never block traffic. It cannot. It has no options for it. FastNetMon only can notify your equipment and ask politely to block all traffic. But in this case, we haven't finished this step of configuration, and FastNetMon only blocked this host, mark it as banned, but it's only action FastNetMon actually did. It can show you like this specific host exceeded hard-coded value of threshold. Why it blocked host after 23,000 of packets per second? Because default configuration option in FastNetMon to block host after host reaches 1 gigabit of bandwidth or 20,000 of packets per second. Of course, those values are not suitable for any network. I would say you need to change them all the time. And you need to understand what is the value when your routers will start degrading traffic, and change them. But you can see for this case, default option worked well. What we can do next? So you can see no changes for a MikroTik, and it's absolutely expected because on this step, we just need to confirm that attack actually happened. You may implement script as you saw on my graphs, that identify your network engineers, call people, escalate problem to start looking something happened. It's first level of escalation, and then look, we have DDoS attack, and then you need to sort it out. So what else we have here? So in addition to FastNetMon client, we offer API. It's actually extremely simple. It can be easily scripted. But in this case, of course, we blocked this host for testing purposes. And in normal circumstances, only one way to remove a specific BGP announce or blocked host to restart FastNetMon, which is not great. So that's why we have a command line interface, which can list every single blocked host by FastNetMon. And in addition to this great option, it can unblock it because we blocked this host for no reasons. It was for test. Let's unblock it. In addition to get ban list, we have two commands, unban and ban. So this, for example, look what actually happened. I stopped the official stream of bytes, and look what happens. So some traffic will slow down a little bit, and we need to wait some time until FastNetMon notices that there are no traffic for this host. And great thing about FastNetMon, you don't need to unblock host manually. You can set threshold and time when actually host will be unblocked. By default, it's about half hour. And of course, for test environment, it doesn't work well, but you can change this value. But so we are not going to wait for half hour for FastNetMon to automatically unblock. You can see traffic back to normal. It's about 10,000 packets per second and less than 1 megabit. It's definitely not an attack. Let's unblock it. Unban, same host. So, perfect. Oh, sorry, mistake. Let's try again. It's FastNetMon API client, unban. So, it's unblocked, and it will not be blocked again because we can see the traffic is normal. It's not exceeding any thresholds, and CPU load is normal, 0, which is great. So, what we can do next? So at this point of time, we have quite a second. So next thing, the most important thing we need to change for our integration is to integrate BGP protocol. It's also not that complicated. So in my tests, I will use GoBGP. Why we use GoBGP? Of course, FastNetMon supports ExaBGP and GoBGP, but I would say that we recommend using GoBGP. And GoBGP offers really great support of BGP protocol, lots of options, extremely easy to understand and debug. It offers API, it offers command line tool, and you can see configuration file. It's really simple and transparent. As you can see, this configuration file you need to create on left side to establish peering session with your MikroTik or your upstream if you don't have BGP by yourself. It's extremely simple. You can see it's autonomous system number, it's your router ID, it can be actually many number, not so many routers check it, a default port, and it's your neighbor. It may be your MikroTik's box or it may be your upstream. It's up to you. We support both options. So it's autonomous system number of remote machine. It may be IGP or eBGP. So no problem about it. Maybe different autonomous system number, same autonomous system number. Of course, because I run MikroTik in cloud, I use eBGP multi-hop to avoid to disable explicit TTL security. But if you run it directly between machines, you don't need this option, and it will work without this option at all. So, and then for every single peer, we need to set IFI, SAFI options. So because we are going to use IPv4 unicast and IPv6 unicast. That's all options we need for black hole or prefix diversion. That's all. And on the right side, it's only options you need to change actually on FastNetMon side. You just need, again, as with NetFlow, you just need to enable it. And then you need to enable annonces for host. And you need to set specific value for community, because it may be specific for your network, because not every single network, of course, uses 666. Your apps may use different one. And then you just need to check. That's all actually you need to change. It's extremely simple. And let's do it. We will use, again, screencast. Favorite thing about this screencast, because my presentation will be published on INNOG website very soon, and you will find out every single link I reference here, every single link on YouTube video, and every single link on screencast. Best thing about this screencast, look, when I started, it's not video, it's text. And because we are going to make lots of changes, not lots, but quite significant number of changes, you can change and copy paste in your configuration. You cannot do it with video, but it's my favorite part about Askinima surveys. It's really great. You can look what I'm actually doing and just copy and paste configuration options, every single of them. Let's do. GoBGP is external package, external app for FastNetMon. We have a really great and complete integration via GoBGP's API. But you need to install it manually. It's not that complicated. We recommend using specific version, because we haven't tested this latest version of GoBGP, and there is new versions that sometimes it may be broken. That's why we recommend using a little bit late, not freshest version. It's 2.16. But you may try this latest one and report like it works fine, and we will update it. So no reasons to avoid it, but it's the only version we tested. So we just need to install it. And first thing about GoBGP, it's implemented in Go language, and Go language is cross-platform. It's not like C or like Python. You don't need any dependencies. You just need to download binary, and it will work on your machine. So that's what we do. Look, so we downloaded binary package. We created folder in OPT to avoid conflicts with system packages. For example, if you already have GoBGP installed. See, we have both binaries. They're quite heavy, but so that's where main benefit of Askinima comes into play. So we need to create configuration for GoBGP. And when you will watch this video in calm environment or not so calm environment in the middle of night, you will be able to do this thing, like what Pavel did, yes, and then move it away to your configuration. So it's exactly configuration file I saw on my previous slides. Very simple. Autonomous system number, neighbor, enabled protocol families. That's all. So I think we can skip it because we already discussed it. So next thing, because for GoBGP we need to create systemd unit file to start GoBGP on server start. It's not something new. We just need to create boilerplate systemd unit file, because it will save lots of time for you when actually you restart machine, you can see it will just run everything again and your BGP session will be active. So we created a time to start GoBGP daemon, enabled on machine's boot. And look, is it alive or not? No, yeah, exciting, it's alive. You can see it's very detailed configurations. It also reports like some peer is added but not established. So GoBGP is really nice and convenient to work with. So you can see, next step, we need to enable configuration integration between GoBGP and FastNetMon. So we saw it on previous slide. We just need to enable GoBGP on, enable annonces for host, and change community number if it's different. That's all. Again, keep in mind, restart FastNetMon. It's also a constant source of changes, complaints to FastNetMon that FastNetMon doesn't work, and people quite commonly forget to restart it after making changes. If you see anything weird with FastNetMon, just try restart it. Very likely that you just forgot to restart it to apply configuration options. So,
Pavel,
yeah,
it's 5:39. So it would be good if you can finish maybe 5-10 minutes. So then we will have some time for Q&A as well.
Yeah, sure. We're almost done. It's later steps. Okay. So let me skip a little bit. So we need to restart FastNetMon itself. And next thing, let's try blocking some specific host. Again, we can use FastNetMon API for it. So we block it host 077. Let's open our old friend FastNetMon client. You can see this host was blocked. And in this case, it was manually blocked. And of course, we expect zero traffic. And let's look on power of GoBGP. GoBGP offers great API. And it offers great command line interface. You can find out what's actually happening with our neighbor. Look, it's really nice. It's very convenient. It's very similar to stuff what you can see on Juniper or Cisco boxes. So we can see that BGP session established. All routing families are enabled, advertisers receive it. And also we can confirm that we have one advertiser prefix, which means actually GoBGP works fine, and FastNetMon integration with GoBGP works fine. So FastNetMon created announce, and GoBGP announced it to your peer. So simple, very simple configuration, very simple installation. And in latest versions of FastNetMon, we are going to include GoBGP as part of FastNetMon's package to avoid your complex steps about downloading, installing. But for now, we're just trying to be as much as possible flexible. And you can see how it actually looks from perspective of GoBGP. We announced network, which is in this case prefix /32, next hop 000, and community private 1 and 66. It works, which is great. And one more step, what we need to do. So let's go back. Finally, so as I mentioned, FastNetMon uses default threshold configuration for 1,000 of megabits per second and 20,000 of packets per second. Of course, it will not work fine for your network, and you need to change it. It's up to you to decide about such values, and you will know after having like few attacks. You will notice when you actually network start degradation. And you can adjust such values. It's again, everything here is FastNetMon conf. If you want to use different values for specific host instead of using single global value for every single host, you can use host groups. Again, it's very simple. Just list networks and specify different values for host group networks. Final steps, final presentation and final video. We are going to integrate a FastNetMon, 1 second. So we are going to integrate FastNetMon's BGP session with MikroTik. 1 second. So what we are going to do, from a MikroTik perspective, we just need to create BGP peering session with FastNetMon. And also we need to apply some changes to interpret incoming BGP annonces from FastNetMon as black hole to enable logic to discard all traffic coming to this prefix on MikroTik side. And we will do it. So first of all, we need to change MikroTik instance to default private ISN. Of course, it will be real in your case because this one is lab. Then we need to create a peer to establish BGP session between FastNetMon and MikroTik. And in this case, it's IP address of machine with FastNetMon installed. So multi-hop, it may be not needed for your case, but if you use it remotely over a few hops, you must set it. Hold timer, yes, I recommend setting to 30 seconds to avoid stale records in case of something happens with FastNetMon's machines. And also we will need to set non-standard incoming and outgoing filters, because that's where magic happens. Let's create them. Apply, okay. Yay, you may notice that state changed to establish it, which is great, which actually means that we did everything right. So we successfully established BGP session between FastNetMon and MikroTik, and after that point, it will work fine. So a little bit more changes, but for so far we done with this step. It can be actually confirmed from opposite side. We saw exact same information on previous step when we check at configuration of previous Go BGP. So let's look what happens. Let's create filters. Okay, before we need to open every content of routing table on MikroTik, because it's where we can see that we changed routing policy for this specific /32 network. Next thing, route filters. Route filters is a thing which can be applied when MikroTik receives some specific BGP announce. And in this case, what we need to do for every single host received from FastNetMon, we need to apply, and has specific community number, which is 666. We need to mark this route as black hole. And it will cause MikroTik to discard every single bit of traffic to this specific, because that's what we are trying to accomplish. And also it will propagate this specific announce to your upstream, which is second half of our problem. Let's do it, create chain, let's FastNetMon in. Prefix length, we need to allow only /32 announces. And if you are going to use BGP diversion, you also need to change and allow announces in between 24 and 32, because it may happen that you will have both of them. So, but by default for black hole, you just need 32. Next, BGP, we just need to accept announces with community 666. Again, to avoid some issues from when a machine with FastNetMon announce something different for some reasons. We need to accept this announce. That's most important. It will propagate it to upstreams. And more important thing, we need to set type. Black hole, which is will discard every single bit of incoming traffic and attacks traffic. That's our plan. So we created a BGP peering session. We can see on the middle of the screen how actually a routing table looks like on MikroTik. It's actually what happens. Oh, okay. It's actually happened way faster, like a little bit late. Look at this again. We used FastNetMon's API to block specific host. It will be exactly the same actions if FastNetMon detects it automatically, because some host exceeded threshold. And you can see FastNetMon using BGP protocol created black hole announce on MikroTik's routing table. So this announce will be propagated to upstream. And at the same time, MikroTik just at this point of time, it started blocking all traffic to this host. So mission accomplished. In real world, you may notice it as immediate drop of traffic. I mean, attacks traffic, and your network will start getting to know. So you can see we receive one prefix from FastNetMon, which is absolutely expected. So let's unblock it and look how fast announce in the middle of the page disappears. So no, fine, disappeared. So 1 second. And that's all. We implemented a configuration of FastNetMon with MikroTik, which can detect when some host on your network is a target of DDoS attack, and then block it on MikroTik itself, and then propagate information and ask for help from your ISP to block all traffic using BGP black hole capability. So all the time, of course, it's just basic configuration of FastNetMon. And if you have more complex questions, if you have questions about specific vendors, specific scenarios, you can see on this slide, we have great community. Lots of people will be ready to help you. Lots of people implemented FastNetMon in all weird configurations, using all weird vendors. Just ask them, just reach us all the time. We are very open for feedback, contribution, using all possible channels. So thank you for attention, and I'm ready to help with questions.
Thanks, Pavel. It was really good slides. Can start with the questions as I've posted in chat. So we have two questions. One is from Tashi. He's asking, can FastNetMon also detect slow DDoS attacks or just volumetric DDoS or DDoS attacks for now?
It's a great question. Unfortunately, FastNetMon is focused on fast and high bandwidth attacks. So we focused on volumetric attack types. If somebody trying to slowly pull some very specially crafted packets on few packets per second rate, it will fly under the radar of FastNetMon. It will be out of the interest of FastNetMon, because FastNetMon cares about something which is more like hundreds megabits or gigabits, and low attacks are not best thing for FastNetMon to detect, and FastNetMon is not built for this purpose. And to defend this kind of attack, I can recommend using special boxes or maybe cloud scribing services, because mitigation for this kind of attack is quite complicated, because even setting of thresholds is extremely complicated, and full filtering is needed in this case, because FastNetMon is not processing live traffic. Or we just receive information what we can see from MikroTik or different vendors, and NetFlow unfortunately has no information about ways how you can actually misuse protocols like flow lorries or different types of complex TCP attacks or attacks against HTTP services. And unfortunately, in this case, we cannot help.
Okay, moving to the next question, Mr. Ajay Kosla, he has asked, can we install it as a pod with Kubernetes using Flannel or Calico CNI?
It's a great question. I think it may work fine, because only one issue you may experience with Kubernetes, because Kubernetes sometimes has issues with delivering UDP traffic to service. And you may need special configuration of load balancers to deliver exactly same traffic to exactly same instance all the time. But I think we have multiple customers running FastNetMon Kubernetes, and it works well enough. So they also run quite complicated configurations, load balancing with high availability in different data centers. And also we have official images for Docker. You can try deploying it, so you even don't need to install it manually, create your images. So just try it. And again, we are very open to all new ways how you can actually deploy FastNetMon, and we're really happy to see interest from people deploying in Kubernetes.
Cool. Going to the next question from Ankan. He's asking, is there support for NetStream protocol?
Sorry, can you repeat?
Does it support NetStream protocol?
Yes, of course. Actually, it's quite misleading sometimes from vendors, because many times I mentioned in my presentation NetFlow protocol, but problem is NetFlow is trademark owned by Cisco, and in many cases you may see exactly this protocol internally. It's NetFlow protocol called JFlow, NetStream, CFlow, SFlow, NetFlow, like many of them. So, and indeed we support NetStream from Huawei, and we have many customers using Huawei, and it works just perfect.
Okay, going to the next question from Daryl Swir. Route black hole versus raw table drops on pre-routing chain. I think latter is more CPU efficient. Any comments?
It may be a case, yes. I because sometimes it depends on implementation. I saw many performance evaluations about, like, in some cases IP tables may be faster, in some different cases routing may be faster, because MikroTik in particular case, it runs on different hardware. It may be well optimized like Tiller boards used in a cloud router. They may have some optimization for routing. But in same case, firewall filters may not be as efficient as possible. And actually, that's the reason you may find out we have community contributed API integration between FastNetMon and MikroTik using API. Because in case of BGP, we are very limited by what actually we can only just create black hole routes, but we cannot create firewall rules. And in integration of which is based on API, not BGP, you actually may create firewall rules. And for many platforms, it may be very efficient. Or you can actually try both of them at the same time. You may create BGP channels, and at the same time, after that, you can block it using firewall. But I recommend all the time doing tests using spare routers outside of production environment, just to understand what is the impact of your changes, how much you can absorb of malicious traffic, what's your peak performance of your routers, just to avoid learning this information in production. Because otherwise, replicating these kind of issues in production can lead to degradation of your network. That's why during the initial deployment phase of FastNetMon, you need to keep your eyes and understand your network very well. What's your peak capacity? What's your peak performance of routers, of your upstream? Because in many cases, actually, we discovered issues when actually upstream was a problem, because some packet rates saturated some links with over-provisioned routers or switches in some cases. That's why we recommend doing all kinds of extensive tests before going to production.
Plus to add to that, ultimate goal is not in most of the cases to black hole at your network level. Of course, you will start with black holing at your router, but ultimately you are going to propagate to your upstream. So once you propagate to your upstream, the traffic stops hitting your router. So it does not matter what mechanism you are using at this point of time to block it. So that's also important reason, because many ISPs say running with a gigabit, couple of gigabits of upstream. If they are bombarded with 10 gigabit of attack, black holing is the option, or scrubbing is the option. You can't have any sort of appliance cleaning things up because your upstream is choked totally. So that's one of the case. I'll go to the next question. So from Ankit Rathod, hi, whether ASN 666 community is followed by all upstream provider by default, or we need to make setup? Maybe I can answer this one in Indian ISP.
Please do.
So I think it's not standard, at least for Indian ISPs. I've seen some of them use different communities. Plus, also it's not enabled by default in many of the cases. So you would have to open a ticket with your upstream to ask them to apply to update their import policy or the import route map, so they accept it.
Yeah, I would say according to our experience, most of the ISPs actually support black hole. But all the time, it may be different community number. Sometimes, unfortunately, you may need to pay for it. In some cases, you may need to pay enormous amount of money for it. Some ISPs, unfortunately, they just don't care. They have no support for black hole. It's typically for monopoly ISPs, which has no great competition, and they just set their own rules. And in some cases, it may be quite tricky, because for some companies, they actually use different BGP session for black hole. And that's the reason when FastNetMon can be handy, and you can actually, in addition to BGP session from your routers, you can establish to your upstream, you may keep additional BGP session from FastNetMon to your upstream directly. It's quite beneficial setup, or you can actually keep both of them. So because in some cases, it may be beneficial, because if your router is overloaded for some reasons, especially if you keep BGP full table, it's quite resource intensive to just process it and all incoming annonces. And when your router is soft router and it's under load, it may be beneficial to just push your black hole annonce directly to your ISP and avoid your routers. Because in some cases, it may just save your network, because it may be faster a little bit, or your route is delayed a little bit. So, and then you can do it.
Yeah, plus, on the part that some ISPs would ask you to pay for it, I often advise people that they should understand that when they are negotiating with their upstream provider, what they are actually asking for. So in this scenario, it's just a configuration change. It may take them a while if they don't have that as a support. If they don't have support for that at all, it may take them a while to apply it. But once it is there, beyond that point, it does not really cost an upstream provider, because keep in mind, they would have similar setup further with their upstream if they are a small provider. If they are a large enough provider, they would have similar support across all their routers, because that's how you bear a large attack. If you have like 40, 50 gigs of attack, say sitting in while you're sitting here in say Delhi or Mumbai or Chennai, that traffic won't really come from India. A large part of that traffic would be distributed. So essentially, you want a mechanism where you block it as quickly as possible instead of letting it to go through the backbone. So keep in mind, once your ISP supports it, beyond that point, it does not really cost them much. It's they would just stop the attack, or they would just signal their upstream further to block it. And beyond that point, it's not going to take much of their bandwidth either. And we can go to the next question. Again, a question from Mr. Ajay Khosla. Is it memory-based, or is it also require persistent storage?
It's memory-based.
FastNetMon
is only memory-based. So everything needed for attack detection is memory-based. But FastNetMon can export bandwidth for hosts, networks, total bandwidth per protocol load into external daemon, which typically is InfluxDB. And in this case, this daemon will need disk storage, but FastNetMon can work on machine without hard disk at all. So if you have an Raspberry Pi, you can just disable logging on FastNetMon and it will work perfectly fine. So we never store all information about attack on hard disk, because in some cases it may be hundreds of thousands packets per second, and back in 2014, hard disks were like spinning crust mostly, and it was just impossible to store all this information. That's why we avoid using any dependency on hard drives.
Cool. There's a question from Ankan. Typically, how much time we need to wait to unban attacked prefix, as RTPH traffic blocks all the traffic for that prefix at the source. So I think maybe you can tell from your experience, should they wait half an hour? Maybe that's too long, or should they wait 10 minutes? Because if the attack is really high, a smaller number essentially would cause a lot of fluctuation, right? You unban the prefix, you set a lower value, it automatically unbans the prefix, you again get an attack, it again goes through a chain of maybe 20, 30, 40 seconds. And then you again block it. So should it be 15 minutes, 30 minutes, 1 hour? Any advice?
I think safe option for 15 minutes. But unfortunately, it depends on bad guys' behavior, because all the time somebody starts this attack, and it depends what drives them. Like sometimes if they're attacking like financial services, they have unlimited budgets. They can attack you for quite long period of time and with quite serious amount of resources. But unfortunately, this kind of attack is quite rare, and 15 minutes work for most of them, because people will try to block it. They will notice that something blocked it, but network is still running, and at some point of time, they will stop doing it, because, what is the point? Because network is still alive.
Right. He also has an additional question. Does it support flow spec?
I would say yes, but it's not. It's more level. It's not general availability support. You can find this option in a community version, but it's just a list of hard-coded rules. For example, FastNetMon can detect this attack as NTP or DNS and create pre-created hard-coded list of rules to block all traffic coming from port 53 or all traffic coming over UDP protocol from port 1 to 3. That's all, but it's more like, it's not production ready, it's more experimental.
Okay.
But we can see a great opportunity for improving it in this direction, because FlowSpec is a great protocol for not only detection and black hole, but only for precise filtering and keeping your host alive.
Sure. It's kind of interesting. We have two people asking questions, one after the other. Maybe you can feel free to unmute Mr. Ajay and Ankan. If you like, we can have it in more of a discussion fashion rather than Q&A manner. And I see a question from Mr. Ajay, follow-up question. Can it be integrated with Memcache or Redis?
It depends on your purpose. Actually, we support integration with Redis. And Redis integration, it's more, FastNetMon just stores all information about a specific attack as key in Redis, and you can read this information from your application or for your reporting system, or you can use this information to apply some post-processing, can make custom logic. So only Redis, but it's extremely similar to Memcached.
Cool. And a follow-up question from Ankan: is there a way to check attack type?
FastNetMon can find out some basic types of attacks, but I would not say that this approach is quite detailed. It can find out like UDP flood, scene flood, fragmented flood, but that's all. Because I actually had different presentation about types of attacks. It was on UK INNOG conference about DDoS detection challenges in IPv6 environment. And I had multiple slides about attempts to classify types of DDoS attacks, especially on volumetric ones. And it's quite complicated because attacker side can use all ways, all fields in actually IP packets to use them for as attack. They might vary TTL field, like a fragmentation field, like window size for TCP. And that's why we are not trying to find out what is the attack type, because actually for FastNetMon, because we based on thresholds. If threshold exceeded, we block host. So it doesn't matter what kind of attack it was. So if you want to understand what kind of attack, you may post-process information provided by FastNetMon. Again, you may read this information from Redis. And in Redis, you may find out sample of attack. And sample of attack is all information: what was protocol, what was port number, how many hosts were involved in this attack. And then you can make decisions like what was type of attack, or you can contribute to FastNetMon to improve our own detection. But don't expect magic from our attack type detection. We can detect attack, but detection of attack type is quite complicated, unfortunately.
I think many people get used to it because a couple of premium vendors would send you fancy reports with PDF and all those crispy graphs showing this was the type of attack, this was the threshold, these would be. So people have that sort of mindset when they're looking for a DDoS protection solution.
I completely agree. Yes, visibility, understanding. So, but our focus is a bit different. We try to find out like what happened and block it as fast as we can. And reporting, it can be implemented, but it's not our goal, I would say.
Sure. So I don't see any more questions here, and I think we can probably shut the session. It was really good. Almost exactly 2 hours 1 minute past the time when we started. So really good. Thanks a lot, Pavel, on behalf of INNOG community for
thank you for inviting. It was a pleasure talking on conference.
It was very nice, Pavel, and it was quite exhaustive. You could have answers for all of them, and I need to study this after implementing it and see how we can use it. Very, very useful. Thank you so much.
I know.